This is our globe. And if we zoom in a little bit into the North American continent, right into Arizona, we can spot an odd-looking hole in the Earth's crust. This is the Barringer Meteor Crater, the biggest meteor crater on the whole planet. However, if you believe the world will one day end due to an asteroid, you probably should think again, since the end could also come from immediately beneath your feet. If we zoom into the United States into the northwest of the continent, as we get closer you'll be able to see an intermittent scar of volcanic mayhem located in the Yellowstone National Park. This area is home to the famous Yellowstone Volcano and is stretching 350 miles next to the borders of Wyoming, Idaho and Montana and is dating back 18 million years. Supervolcanoes are likely to have killed more people than asteroids, and the Yellowstone supervolcano is one potential candidate for such a destructive event. Although it was previously thought that these gigantic volcanoes would take thousands of years to build and remain trapped beneath the Earth's crust for an equivalent amount of years before having any impact on the world, new evidence shows the opposite. According to a recent study, these cataclysmic eruptions, thousands of times more powerful than Mount St Helens' 1980 eruption, could occur at any moment. Is humanity on the eve of a great misfortune? Is it possible that a supervolcano is about to erupt? What unfortunate circumstances could cause this? The end of humanity could be right beneath our feet, and this is terrifying. Few things can compare to the awe-inspiring power of a volcanic explosion. They cannot be halted or avoided. But what exactly is a volcano? And how does it erupt? Let's first have a look at some interesting geography. Many mountains were formed by the Earth's crust bending, faulting, uplifting, and erosion. Volcanic landscape, on the other hand, is formed by the slow accumulation of erupted lava. Through a succession of fissures, within and beneath the volcano, the vent may be seen as a tiny, bowl-shaped depression at the summit of a cone or shield-shaped mountain. The vent is linked to one or more molten or partially molten rock or magma storage places. Because of this connection to fresh magma, the volcano can erupt repeatedly in the same location. As a result, the volcano expands until it is no longer stable. When molten rock beneath the Earth's surface rises through volcanic vents, pieces of the volcano collapse as rock falls or landslides. It is referred to as magma. However, when a volcano erupts, it turns into lava. Magma is composed of molten rock crystals and gas. Consider an unopened bottle of Coke with sand inside. The chemicals oxygen, silicon, aluminum, iron, magnesium, calcium, sodium, potassium, titanium, and manganese make up the molten rock. After cooling, molten magma may form crystals of various minerals, until it solidifies and creates igneous or magmatic rock that originated tens of miles beneath the ground. Magma is lighter than the solid rock that surrounds it. Buoyancy propels it towards the Earth's surface. It is lighter than the surrounding rock and is held together by the pressure of gas within. Magma pushes upward and may eventually break through weak spots in the Earth's crust. If this is the case, an eruption will be happening. Magma can erupt in a variety of ways though. As fluid lava flows, molten rock occasionally streams from the vent. It can also shoot dense clouds of rock fragments, tephra, and gas into the air. Larger particles fall back around the vent, and tephra clouds may flow down the volcano slope due to gravity. Tephra, ash, the thickness of a strand of hair, may be carried by the wind and fall to the ground many miles distant. The smallest ash particles can be ejected miles into the sky and carried several times around the planet by winds high in the atmosphere before falling to the ground. So how many volcanoes are there? The U.S. Geological Survey (USGS) monitors about 160 active and potentially dangerous volcanoes in the United States alone. There are currently around 1,350 potentially active volcanoes on the planet. In the last 100 years, about 500 of these have erupted. Many of these are found in a region that is known as the Ring of Fire, which circles the Pacific Ocean. However, one type of volcano is not included in the figures above: the so-called underwater volcano. You may be unaware of these underwater volcanoes since they occur mostly in remote locations, but that does not make them any less hazardous. In fact, the majority of volcanic activity occurs beneath the sea. The deep sea accounts for 2/3 of all volcanic activity. So, how does an undersea volcano come to be? There is no special distinction in the formation of submarine or underwater volcanoes and land volcanoes. Underwater volcanoes arise when molten rock is created in the Earth's second layer and travels through the crust. As Tamsin Mather, a volcanologist and earth sciences professor at the University of Oxford, puts it, the majority of underwater volcanic activity is related with an ongoing volcanism along mid-ocean ridges where two tectonic plates are moving apart from each other. A collision of two plates can also result in the formation of a volcano. If both tectonic plates are beneath the ocean, the volcano will form underwater, according to Hilo. She noted that they could eventually develop to form volcanic islands. A volcano can also emerge as a result of volcanic activity inside a single tectonic plate. This can occur when a hotspot sits beneath an oceanic plate, resulting in a chain of volcanic islands such as Hawaii. That's why the Mauna Loa volcano, the world's largest volcano, has been continuously watched for centuries. It has been erupting regularly for more than 700,000 years. The U.S. Geological Survey issued a geologic map of the Hawaiian Islands on March 30th that depicts the various layers created by the eruptions of both the Mauna Loa and the nearby Kilauea volcano. The island of Hawaii has 5 above-ground volcanoes: the Kilauea, Mauna Kea, Hualalai, Kohala, and the already mentioned Mauna Loa. The Mauna Loa is not only the island's largest, but is also the world's largest volcano and accounts for more than half of the island's surface area. The volcano has a surface area of 5,271 square kilometers and a maximum width of 120 kilometers. The biggest part of the volcano's massive structure is submerged at around 56,000 feet or 17,170 meters. Measured from the ocean floor's depressed crust to its highest point. That basically means Mauna Loa is nearly twice as tall as Mount Everest. Mauna Loa is prepared to erupt directly in front of us, and its chances of erupting again are believed to be approximately 100%, with potentially catastrophic repercussions, according to scientists. While Mauna Loa is the world's greatest active volcano, the world should hope to escape certain megavolcanoes. It turns out that the question with megavolcanoes isn't whether they can annihilate all life on Earth. It's just a matter of time before it happens again. According to some scientific data, this massive supervolcano that erupted 250 million years ago may have wiped off more than 95% of the world's plant and animal life. Yes, you've heard that correctly. A giant volcano erupted with such fury some 200 million years ago that it wiped out 75% of the planet's inhabitants. It was so large that it split North America and Africa apart, resulting in the formation of the Atlantic Ocean. For 600,000 years, the major volcanic camp, Central Atlantic Magmatic Province, erupted repeatedly. There's also bad news for those of us who live in locations where volcanoes aren't an issue. It wasn't because lava had covered everything or volcanic ash had come down so hard that everything was smothered. Instead, it was the event's aftermath. Pollution, CO2 and carbon levels, for example, have skyrocketed. The environment had suffered damage. Only a few things were able to recover. It's worth mentioning that dinosaurs were able to grow and take over before their own terrible end, illustrating that no one ever triumphs for long. Some rogue scientists, however, believe that dinosaurs were wiped out 65 million years ago by a volcano rather than an asteroid. There have been spectacular underwater volcanic explosions, and we shall discuss their enormous influence. Next, let us tell you about the most powerful underwater volcano ever recorded in 2018, as well as the largest active underwater eruption ever recorded. The incredible part about the eruption is that it gave birth to an enormous volcano, the size of a skyscraper, and scientists are still constantly learning about it. What did they discover? Scientists discovered the 2,690 feet or 820 meter tall volcano in Madagascar's western Indian Ocean, after a strange series of earthquakes that struck near what is normally a seismically quiet area. The scientists discovered a new submerged volcano roughly 1.5 times the height of New York's One World Trade Center after collecting geological data, including information from a 2019 underwater survey of the region. Furthermore, according to senior researcher Natalie Fouliot, a marine geoscientist at the Paris Institute of Earth Physics at the University of Paris, this new volcano draws from the deepest volcanic magma reservoir known to scientists. The reservoir's magma source is approximately 34 miles or 55 kilometers underground. It was the first time in volcanology that such a deep reservoir was discovered near the base of the lithosphere, which is the outer shell of the globe that comprises the upper mantle and crust. Between the months of May 2018 and May 2021, Mayotte, a small island and French territory between Madagascar and Mozambique, was shaken by more than 11,000 measurable earthquakes. The strongest earthquake had a magnitude of 5.9. There were also weird seismic hums caused by very low-frequency earthquakes deep beneath the Earth's crust. They couldn't be felt on the surface, but seismometers around the world detected them. These extremely low-frequency earthquakes are linked to volcanic activity. This unexpected seismic activity was remarkable given that only 2 earthquakes have been reported near Mayotte since 1972, and the last recent volcanic activity was left at least 4,000 years ago. Scientists were astounded in July 2018 when they discovered that Mayotte was moving eastward at a rate of 7.8 inches or 20 centimeters per year, as measured by GPS data. Because the island only had 3 or 4 GPS stations at the time, scientists deployed global navigation satellite systems and ocean bottom seismometers around the island to learn more about the geological changes taking place there. The findings were astounding. Between February and May of this year, the combined land and ocean bottom seismometers recorded 17,000 occurrences. Underwater volcanoes can cause huge and strong eruptions, but they can also sometimes go unobserved, forcing scientists to put together all the information they can gather. This was the case with the 2012 Kermadec Islands eruption, the greatest deep-sea volcanic eruption on record, which prompted experts to investigate a 5-meter-thick floating raft of pumice, a certain type of rock that covered 400 square kilometers of ocean. Some of these hunks of pumice are the size of SUVs and were strewn across kilometers of seafloor. 14 lava flows and a thick covering of sticky ash were spotted. These are the hints that scientists are hoping will help them solve the riddle. The greatest deep-sea volcanic eruption on record occurred in 2012, when the Havre Seamount exploded in a volcanic eruption that was approximately 1.5 times the size of the famous Mount St Helens eruption in the United States. Nobody detected the explosions from the Earth's crust until a few days later. That was when an aircraft passenger gazed out the window as she traveled 800 kilometers north of Auckland over the Pacific Ocean. She observed a massive floating raft of pumice and hurriedly snapped the shot to send to a geologist. Unbeknownst to this passenger, she had launched an international investigation into the enigma of an underwater volcano. Later that year, in October, the new research vessel Tangaroa performed an echo sounder survey of the Havre Seamount volcano, making a map from the data. Scientists observed that the map differed significantly from how the seamount appeared when it was discovered in 2002. This really confirmed previous evidence that Havre was the volcano that erupted 3 years later. A group of scientists traveled to Harvard with the intention of creating a more detailed map of the volcano, as well as taking images and collecting rock samples. Of course, the scientists were hunting for evidence of undersea eruptions, which are hidden underneath hundreds of meters of seawater. This made studying tough, until an invention came to the rescue. ROVs, or remotely operated vehicles, are underwater robots. A fiber optic cable connected Jason to the research ship, letting the operators to view what the ROV was looking at as they drove it about. The underwater robot could also take pictures and collect samples. The automated underwater vehicle, AUV Sentry, was programmed to take images and monitor water chemistry along a predetermined path. The team had created a far more detailed computerized map of the volcano at the end of the journey. This map revealed many lava flows, a thick ash layer, and millions of massive pumice blocks up to 9 meters in diameter, scattered across the seafloor. The robot also gathered a considerable amount of pumice. The nature of the eruption was one of the things experts tried to figure out. Volcanoes could be explosive, or they could be a fugitive explosive. The volcano erupts, whereas effusive means that lava flows continuously from a vent. The scientists were at a crossroads since the ash supported an explosive eruption, yet the pumice and lava point to a fusive eruption. Another eruption, the Krakatau's volcanic explosion, was more recent, but not less destructive. It had been rumbling for months before erupting on April 26 and 27. The explosive eruption of this stratovolcano, located along a volcanic island arc near the Indo-Australian Plate subduction zone, ejected massive volumes of rock, ash, and pumice. The terrible roar was heard from several miles away. The volcanic explosion also resulted in a tsunami with maximum wave heights of 140 feet or 40 meters. More than 7,000 kilometers away, the Arabian Peninsula saw an increase in tidal gauge wave heights. The tsunami recorded a tragic death toll of over 34,000 people. The Krakatau Island was completely destroyed by this massive eruption. New eruptions, beginning in December 1927, erected the Anak Krakatau, or Child of Krakatau cone, in the center of the caldera formed by the 1883 eruption. Anak Krakatau appears out of nowhere and constructs a new island in the shadow of its parent. Speaking of volcanic eruptions, let us tell you about why the Huaynaputina volcano is the site of South America's greatest volcanic explosion ever recorded. The explosion was so powerful that it propelled mudflows 75 miles, 120 kilometers down to the Pacific Ocean. Scientists believe the eruption, that happened in the year 1600, influenced the global climate, since the summers following the eruption were among the coldest in 500 years. The explosion's ash deluged a 20 square mile, 50 square kilometer area to the mountains west. The ash is still visible today, although Huaynaputina in Peru is towering at 16,000 feet, 4,850 meters. It is a bit sneaky in terms of volcanoes. It stands on the rim of a deep canyon, and its peak lacks the spectacular appearance that is commonly associated with volcanoes. The Huaynaputina volcano caused damage to the nearby cities of Arequipa and Moquegua. It took them more than a century to recover from this event. The Thura volcanic eruption in Greece was another unfortunate event that destroyed the island of Santorini and impacted the entire planet heavily. Scientists believe that if the volcano had not erupted 3,500 years ago, the world map might have looked different today. The Thura eruption is thought to be the single most powerful explosive event ever witnessed, blowing a big hole in the island of Santorini and altering the path of the ancient Mediterranean. The eruption had political ramifications as well. It annihilated the Minoan culture, which was prominent in the region at the time. While historians and archaeologists disagree on the year, hypotheses have proliferated. There have been various dates proposed ranging from 1645 BC to 1500 BC, but there is no doubt that Thura erupted with unprecedented force, as evidenced by ash deposits, which were discovered on the ocean floor. The picture would have been easier to pull together if there had been a first-person account of the occurrence. However, researchers have made comparisons to the Krakatoa volcanic outburst. Thura killed around 40,000 people in just a few hours and created 40-feet-high tsunamis. It also spread volcanic ash across Asia, causing global temperatures to fall. For 3 years, it even produced bizarrely colored sunsets. The terrible explosion was heard by many people up to 3,000 miles away. Scientists believe it was possibly 4 or 5 times the size of Krakatoa. In a fraction of a second, it exploded with the energy of many hundred atomic bombs. Meanwhile, experts have discovered no human bones or treasures belonging to Santorini's Minoan occupants. This means the people there were probably able to forecast the eruption and evacuate the island on time. Soon after the explosion, the great Minoan civilization was doomed to abruptly fall. Tsunamis caused by the eruption would have first and foremost destroyed its naval fleet and coastal settlements at the beginning. According to historians, the large amount of sulfur dioxide emitted into the sky must have caused years of chilly, wet summers in the region, destroying agricultural crops. In fewer than 50 years, the devastating combination destroyed every significant Minoan fortress. This produced a political vacuum in this region, resulting in the warring city-state system of ancient Greece, which would dominate the Mediterranean. The Aegean would turn out to be a major building piece in European history, and the Minoan demise significantly altered its early foundation. So, is it likely we are going to face another cataclysmic eruption in the foreseen future? In a nutshell, yes. Yellowstone National Park is home to a chilling nightmare that would, if it erupts, frighten everyone on the Earth, not just you. If the Yellowstone supervolcano were to erupt, it would highly likely bring the entire world to its knees and extinguish most or all life on the planet. The Yellowstone volcano, which is estimated to be 2,100,000 years old, has erupted approximately every 600,000 to 700,000 years since its formation. We don't know if the supervolcano would erupt in the same way it did in the past because the last eruption was 640,000 years ago. But if the Yellowstone supervolcano decides to erupt, we are certainly not the first civilization to be threatened by a giant volcano. Mount Vesuvius, another well-known supervolcano, is famous for destroying an entire civilization in the year 79. The eruption received an 8 on the VEI index. Archaeologists are currently excavating Pompeii's ashes in search of ancient treasures and the charred bones of those who perished in the fire. While scientists monitor earthquakes, ground deformation, stream flow, and temperature changes in Yellowstone, it's unclear how much of a warning a supervolcano will give us before erupting. On a regular basis, smaller eruptions from supervolcanoes relieve the pressure in the magma chamber. In the 640,000 years since Lava Creek, more than 18 non-explosive lava eruptions have occurred at Yellowstone. This means a future eruption is more likely to be the scale of Pinatubo than a supervolcano. But what if we get dealt a bad hand? What would be the consequences of a Yellowstone supervolcanic eruption? Most super eruptions occur in areas that have been active for millions of years but have since gone silent. So don't put your faith in Yellowstone's apparent tranquility. In most circumstances, longer dormancy leads to larger growth. Yellowstone is situated on a long, active tectonic zone, with a weakened and thin crust resting on a 2,500 Fahrenheit, 1,370 degrees Celsius magma dome that is rising from the upper mantle. This dome, like other supervolcanic places, has melted and broken through the crust, generating 2 enormous magma chambers that are 5 to 7 miles, 8 to 11 kilometers beneath the surface, and both measure more than 30 miles, 48 kilometers in width. These magma chambers are filled with a mix of semi-solid molten rock and dissolved gases like carbon dioxide and water vapor. Over hundreds of thousands of years, more magma accumulates, delivering more heat and pressure and eventually forcing the top ground upward. Pressure builds in a cyclical process known as incubation when a consistent supply of hot magma is fed to the chamber. If not, some of the material will harden and sink, releasing pressure. Because of a supervolcano's huge magma chamber, the incubation demands a heat supply rate that is 2 to 3 orders of magnitude more than that of a conventional volcano. As a result of the increased pressure, fractures emerge along the dome's periphery, allowing air to escape the chamber as the gas-filled magma erupts. Fast-moving pyroclastic flows spew dense clouds of gas, ash, and debris, boiling out from the eruption with temperatures of 1,470 degrees Fahrenheit or 800 degrees Celsius. Additional regional blasts will be sent out on a weekly basis. Ash falls to the ground, contaminating the atmosphere and covering tens of millions of square miles with inches of crop-killing ash and debris. Anyone within thousands of miles of the explosion runs the risk of breathing microscopic glass needles, bursting pulmonary blood vessels, and drowning in an ash and lung moisture slurry until it settles. As a result of the ash falling from the sky, polluting the water, and clogging car engines, food supply, transportation, communication, and economic crises that can last months or years can develop. Due to an unanticipated buildup of dust and sulfuric acid aerosols over the world, global average temperatures are expected to plunge 5 to 9 degrees Fahrenheit, 3 to 5 degrees Celsius, within a matter of weeks. 3 feet of dangerous volcanic ash would blanket 1/3 of the United States, rendering it uninhabitable for months, if not years. In comparison, a Yellowstone explosion would be 25,000 times greater than Mount St Helens. It wasn't always the lava flows that turned you into ash that killed you. It may be the horrific aftermath from the lava flows into ash that ravaged the Midwest, or it could be the resulting global cooling. There are currently no indications that the Yellowstone supervolcano is about to explode. Apart from evacuation, there isn't much else we can do. As soon as this occurrence occurs, signs arise. Not only would our way of life alter, but so would the global economy. If Yellowstone does not erupt, another mega eruption will occur at some point in the future elsewhere on Earth. Don't you believe it's past time to start planning a Mars colony? Tell us your thoughts about the Yellowstone supervolcano in the comments below.